Lastly, we're going to look at the properties of biodiesel and petrodiesel and try and highlight some of the differences and I guess the bonuses that there are with using either biodiesel or petrodiesel as your fuel in your car or truck engine. So first of all, what are the structures of biodiesel? What is the structure of petrodiesel? If you watch the previous video or the bit before this, you can see the fact that biodiesel is a methyl ester. And you can see here we have an ester functional group and a very long carbon chain. So this one in particular, it goes all the way around here and going all the way down this way. This is methyl oleate, which is the methyl ester made from oleic acid, which is found in olive oil. So if I took some olive oil and I did my reactions that I talked about before, this is the compound that will come up with. If you're comparing that to what petrodiesel looks like, this is an example of what petrodiesel might look like, which is just simply a straight chain hydrocarbon. This one, I think, is octane. Yep, it's 8 carbons, that's octane. So this is probably more so petrol rather than diesel. Diesel's probably got about 12 or 13, 14 carbons, but the deal is the same. Petrodiesel is a straight chain hydrocarbon with no functional groups whatsoever. It's just carbon and hydrogen. So what does this mean in terms of properties? Well, the first thing to think about is the intermolecular forces that are happening within these molecules or between these molecules. If you have biodiesel, it's going to have a much higher molar mass than petrodiesel. It's also got an ester functional group. The higher molar mass leads to more dispersion forces, which means the fuel is going to be thicker. It's going to be held together nice and tightly. The ester functional group provides dipole-dipole forces between molecules as well. These both shout or scream, in my opinion, the fact that we have an increase in the intermolecular forces. So the force holding these compounds together is much greater in biodiesel. Now this is a slight problem because when you have fuels, you want a fuel to run really nicely. You want it to be relatively a low viscosity. You need it to be runny. If you have increased intermolecular forces, you're actually reducing the ability for this molecule to flow along fuel lines. So what happens is biodiesel has a much higher viscosity. It also has a higher flash point because it's harder to actually get vapor to combust. It's also got a higher cloud point, which means it crystallizes easily because you've got those intermolecular forces happening. So in terms of intermolecular forces, biodiesel is not very good. Now in part 5, we're going to talk about the energy content of these two molecules. Now this is going to be my final video about biodiesel and petrodiesel, and it comes down to the last property, in my opinion, one of the most important things of all. It's what does a fuel or what should a fuel actually do? And a fuel should provide energy. You're burning it to produce energy. So in terms of which one is a better fuel, which one actually produces more energy? And to understand this, we need to kind of come back to where does the energy come from? Energy in chemistry comes from the breaking of bonds and forming of new bonds. And in this case, we're doing oxidation and we're breaking bonds between carbon and we're adding oxygen to our fuel. If you look at biodiesel up here, it already contains some oxygen, which means it's already partially oxidized. Petrodiesel down here is only got carbon and hydrogen. What that means is that petrodiesel, only containing hydrogen and carbon, can be oxidized more than biodiesel. And that means petrodiesel will actually produce more energy. So if you look at my little thing over here, biodiesel is already partially oxidized, which means it has a lower energy content. And that is the final little property that we're going to look at between biodiesel and petrodiesel. So over the course of the last 5 or so videos, or the last 5 or so parts of this video, what you see is the difference between biodiesel and petrodiesel, and it helps you understand some of the pros and cons of both of these things. Biodiesel is generally better for the environment, and you need to understand the chemistry behind that in terms of the use of carbon dioxide to produce it, and also the fact that it's renewable. You need to understand the chemical equations that go into making biodiesel, and that type of stuff, basically. You also need to be able to explain the properties of both of these things, and that's what this particular slide behind me was talking about. In terms of choosing whether you want to use biodiesel or petrodiesel as your fuel, you cannot be wrong in choosing either of those. But the most important thing is you need to back up your reason with data and with chemistry. You choose biodiesel because it's more environmentally friendly. You choose petrodiesel because it's got way better fuel properties than biodiesel. And you need to be able to explain all of these using all the information that I've talked about in this series of videos. Hopefully this has helped you understand a bit about these two fuels. Hopefully it's given you a bit of an insight into the chemistry that's required for this topic in VCE chemistry. And yeah, that's basically it. I'm going to stop talking now.